All right, you guys, let's go ahead and get started here with example 1. We do want to go ahead and prove similarity of triangle ACE and triangle PCD. Once again, we do have the big triangle here, which is being highlighted in blue. And then we have our smaller triangle, which is the one in orange. So in this case, we do want to go ahead and solve for the missing side. So in this case, once again, I like to do it by corresponding sides whenever we're doing the ratios or the proportions, which means that BC corresponds to AC, and in this case, CD corresponds to CE. All right, so in this case, let's go ahead and get started here. I will be starting off with the smallest one first, but it doesn't matter which one I start. So I will be doing CB over CA or AC, however you want to see it, and CD with CE. Okay, so in this case, guys, all we're doing is we're basically substituting our values here into the expression, or not the expression, the equation here. So let's go ahead and get started. And in this case, CB has a measurement of 5. CA in this case does talk about all of this here. So it's not just 5, it's also 3, so we do have to include everything, which in this case would be the 8. CD is 4. And in this case, we're looking for DE. So in this case, we still have to incorporate all of CE. So CE is actually 4 plus X. All right. Now, in this case, guys, since these are proportions, we are going to be cross multiplying them. So that is going to be 5 times 4 plus X equal to 8 times 4, which is 32. All right. So in this case, let's go ahead and distribute the 5. 5 times 4 is 20, plus 5 times X is 5X. All right. Next step is to subtract the 20 to both sides. And that would give us a 5X equal to 12. Final step for us here is to divide by 5 and divide by 5. And X in this case is going to equal 12 over 5. Or in this case, DE equals 12 over 5. And that would be our answer. That would be our answer there. All right. So once again, that's us solving for a missing side. And let's go ahead and take a look at this next one. We do have one more example here. And in this case, it says triangle XYZ is similar to triangle PQR. Solve for K. Now, notice in this case, guys, they are telling us how we're reading our triangle here. So X in this case is going to be corresponding to P. Y corresponds to Q. And Z corresponds to R. All right. So since we're trying to solve for K in this case, we're looking for this one. Corresponding side with QR would be YZ. And then we could choose any other side. So in this case, let's say I use RP, which would be in this case ZX or XZ. So let's go ahead and build up that proportion. I have QR over YZ equal to, in this case, PR over XZ. All right, so let's go ahead and substitute. QR in this case is our K. YZ is 10.5. PR in this case is 5.5. And XZ is 16.5. Once again, we're solving for the variable here. So let's go ahead and cross multiply. And that is going to give us 16.5K equal to, let's see, 10.5 times 5.5 is going to be 57.75. All right. So next step in this case is to divide by 16 0.5 on both sides. And let's go ahead and divide by 16.5. And our answer in this case for K is going to be 3.5. And that's our answer. All right.